Welcome back to Ameba 2, and today I will show you topological optimization 2D process through a simple example. On the left hand side, we added a constraint on, and on the right hand side, we have the load that we want to locate it on. So now we open up our Rhino. After open Rhino, we go to top view to create our surface similar to our example. And we turn on shaded view. The pre-processing of Ameba 2 is different to Ameba 1. The following step I'm going to show you how to do the pre-processing for Ameba 2. Now we go to our polyline tool, select and draw over the region that we want to do calculations on for lows. And now we want to split our surface with this line. Now our surface has been split to two. And next step, they want to join them back together. And now it's in one piece, but our geometry has finished the pre-processing and ready for calculation in Ameba 2. Open up Grasshopper. Open up Grasshopper. They have a blank canvas here. Go to our Ameba 2 ribbon. On top of Ameba 2 ribbon, then we select Ameba Geo in order to capture our geometry. Type Prim. Connect our component and set our component to the surface that we created. And the next step is to set the load and constraint on the surface. So we go to Domain 2D, click Load, drop to our canvas and click Support 2D Curve, drop to our canvas and connect our components. And we'd like to put our constraint on the left side and the loads on the right side. So we put our value 0 to constraint and our force downwards from -2, 1, and 0. Connect to our Y component. And now we would like to assign our low and support. So click select on the low and click the edges that we want to assign on. Press enter. That will be showing our load symbol will be shown on the model. And we go to our support, click select, click the edges on the left hand side, press enter. Now we have a constraint on our left side. And then go to our ribbon, click pre-processing component, connect our loads and supports onto the component. If we click edit setting, there will pop a window about our calculation type, topology optimization. The FAM setting is for closed source software calculations. And now here we choose topology optimization calculation. On the next panel that we have materials, we have a ABS, TBU, iron as our preset materials, or you can type in your own material values in order to do the calculation. On the next panel that we have parameters that we usually set our filter radius multiply into 2 or 3 and set as 100 and let the other thing as default and click the left side button to confirm. Over here we go through our Ameba 2 ribbon, click mesh parting, drop down to our canvas, connect our preprocessing info. And we want to give a project name, also a workspace for it. And connect our component to workspace and a 2D test. And below, they'll pop our value range that I want to do our calculation on. In this case, I'll just use 0.1. And then right click the component to press start. And then the geometry has been split to 29,000. And after the geometry has been generated, we want to go to our solver, drop that solver onto the canvas and connect the info to our cloud solver. Open up window. It popped up the window. Here is what Ameba 2 calculation through cloud usually look like. And then we have server in Shanghai at the bottom, or we can interchange to US Silicon Valley. Usually just use the server that are appropriate to your locations. So in this case, I would like to use US Silicon Valley and press start. After we get our calculation data back, we can see this 62 step that went through the calculation. And now if we want to put on displayed, we go to Ameba 2 menu, select display component, drop it on our canvas and connect the mesh into our component. And because it went through 62 step, we're given the 62 step as maximum. And then click on the component. As we can see left hand side, the structure has been generated. So over here, we right click the component, select nice. There we can see the force and the data on the component as through calculations. Thank you for watching. We'll see you in the next tutorial.